All right, hi guys, let's have a look at this question 3 then. So this was the question: you're given that some function is equal to log base 2 of x all squared plus 6 times m, which is a constant, times that log base 2 of x plus n. We're told that m and n are constants and they're real numbers. Okay, and you're also told that this function has a local minimum at the point 1/8 negative 2. And you're asked to find m and n. So what can we take from that? Well, first of all, quite useful is the fact that if I substitute 1/8 into here, okay, that we're going to get negative 2. And you could substitute that directly in and end up with an equation linking m and n and equaling negative 2. That's one possible approach, and that's an approach I did actually take when I did the question the first time. And it can be done that way, but there is also something else that's worthwhile noticing, and it's the structure of this function here. I'd like you to notice, and this comes up quite often in scholarship questions. Let me put that in blue. Notice you've got something squared here. So we've got some function. Let's call this something, I don't know, let's call it a, plus 6 times a constant times a plus n. Well, that to me looks like a quadratic. Now, quite often you can, when you have a look at some of these scholarship questions, this comes up usually in a paper each year at least once. Okay, and where you can replace what looks like a complicated function with some sort of substitution, making it into a simpler function by making a substitution. So let's actually do that. Let's actually take this a stage further. So let's let a equal that log base 2 of x. So we know that this function has a local minimum. So if I derive this function with the substitute in it, we're going to get 2a plus 6m. And yeah, we're told that this, we've got a local minimum, so this derivative is equal to 0 when x is equal to that 1/8. So yeah, let's just make this, yeah, let's take this a stage further. So we can say that 2a plus 6m is going to equal 0. So we can say that 2a is equal to negative 6m, a is equal to negative 3m, but how does that help us get x? Remember that a is this log base 2. So let's put that back now. And what we've got is a basically a function where we can rearrange this, okay? Yeah, let's substitute in that 1/8 now. So we've got this log equation to solve. Now remember that 1/8 is 2 to the power of negative 3, so I'll just fit that in here. So log base 2 of 2 to the power of negative 3 is equal to negative 3m. And we can move that negative 3 to the front, so we get negative 3 log base 2 of 2 is equal to negative 3m. Now, I'll put this over here in a different color. If you've got log of, let's call it anything, n, log base n of n, if these two are the same, it's going to always equal 1. Okay, you need to memorize that. That's simply a fact of logs. You can check it with your calculator. The natural log of e, okay, will be equal to 1. Log base 10 of 10 would equal 1. So yeah, you can check it with your calculator, but that's true. So how does that help us here? Well, this log base 2 of 2 Let's go back to blue. It's going to be 1, so we get negative 3 is equal to negative 3m. Well, m must equal 1. Okay, so if m is equal to 1, okay, how does it help us? Where are we? Okay, so having found m, let's substitute this into the original function. Now remember, we do have the fact that when x is 1/8, the function is going to be equal to negative 2, and we know that m is 1, so basically we have an equation where we know what x is, we know what m is, the only thing we don't know is n, so let's substitute that in and solve for n. So let's do that. So we're going to have negative 2 log base 2 of 1/8, all of that squared, yeah, all of that squared, plus 6 times 1 is obviously 6, so this is going to be 6 log base 2 of 1/8, okay, plus n. So negative 2 equals, now log base 2 of 1/8, well, we've just done that, we just did that here. Okay, and we found out that that's equal to, let's do it over here again, log base 2 of 2 to the power of negative 3 is negative 3 log base 2 of 2, so that's going to equal negative 3. So we're going to get negative 3 all squared plus 6 times negative 3 plus n. So negative 2 is going to equal 9 minus 18 plus n. So 9 take away 18, that's negative 9. So if we solve for n, we get n equal to 7. Alright, so we've got our two values, n is equal to 7 and m was equal to positive 1. Alright, so that was question 3. Okay, alright, so let's have a look and see how you got on with those, and let me know if there's any questions. We'll be meeting tomorrow, okay, after school, just to have a look and see if any questions on this. Right, so catch you in class.